In this video, we're going to talk about angles and how to measure them. So we start with defining an angle, and to do that we need to define a ray and a vertex. Okay, so a ray is a portion of a line that starts at a point. At a point V on the line and extends indefinitely in one direction. The starting point V is called the vertex. Okay, so for an example, okay, so here's a starting point, so that's our V, and then a ray would look like that. Okay, so it goes indefinitely in some direction from that starting point. Okay, so then when two rays are drawn with a common vertex, okay, they form an angle. So one ray is the initial side, is what we call it. Okay, and the other ray, the other ray is the terminal side. Okay, so this determines which way the angle goes. Okay, so for example, let's just draw a picture here. So let's say I have, this is my V, and I have one ray that goes like that, and another ray that goes like that. Okay, so I could define the angle here. I'm going to call it theta. Okay, so that could be, so this is ray 1 and ray 2. So if I talk about theta, then ray 1 would be my initial side, and ray 2 would be my terminal side. Okay, but I could also define the angle going the other direction. Let's call it beta. So if I use beta, I actually have the same, so it's the same initial side and the same terminal side. But it goes in the other direction. Okay, so the idea is if we rotate from the initial side to the terminal side in a counterclockwise fashion, so like we did with theta, then we're said to be moving in the positive direction. Okay, so that means that theta is going to be bigger than 0. If we rotate from the initial side to the terminal side in a clockwise fashion, we're said to be moving in the negative direction. Okay, so here the beta is going to be something less than 0, so we're going the opposite direction. Okay, another example. So maybe I have a vertex, maybe this one goes like that, that's ray 1, and maybe this is ray 2. Okay, so if ray 1 is the initial side, I could define this angle, maybe I'm going to call it alpha. Okay, and then this would be my initial side, and this would be my terminal side. And because I am going in the counterclockwise direction, alpha is going to be bigger than 0. Okay, now I could define gamma maybe to go like that. Now I gotta write the gamma like this. Okay, so now if I use that one, this is the initial side. And this is the terminal side. Okay, but gamma is still positive because I'm going in a clockwise fashion. Okay, so it's still positive, and here, this point here is my vertex V. So they meet at a vertex. So you get to pick the initial side and the terminal side. There is a common way to pick it though, so that's in standard position. So we say an angle is in standard position if its vertex is at the origin. Okay, so we have our XY plane. Okay, so there's X and there's Y. So the vertex is actually the origin. And our initial side is the positive x-axis. So this part here is our initial side. Okay, and then the terminal side can be anywhere along the, in the coordinate plane. So maybe it's here. Okay, so then this we could call angle theta. That would be a positive rotation, okay? Or I could have my initial side and maybe my terminal side is down here. Now if I go around the positive direction, that's going to be positive, but I could instead go this way, which would be a negative direction. So here, okay, so theta is a positive move, and beta is a negative move. So it depends if you go counterclockwise or clockwise. Okay, so you probably are familiar with using degrees to measure angles. Okay, so the angle formed by rotating the initial side counterclockwise until it coincides with itself is a measure of 360 degrees. Okay, so this 360, you might be wondering, I mean, you're probably used to it, so you're probably maybe not questioning it, but why is it 360? That's actually up for debate. Some theories go back centuries to different eras that used different ways of measuring things than we do now. So one is like when there's a culture that used a base 60 instead of a base 10 number system. So 360 would be important to them. There's also the calendar used to be 360 days instead of 364, et cetera, et cetera. So I think this is it could be a cultural way to measure the angle. But if we assume that a full turn is 360, so that's going to mean that 1 degree is 1 over 360th rotation. Okay, so that's how we think about 1 degree. Now, so if I think about it in standard position, okay, so here's my initial side. A right angle is going to be like that, so going counterclockwise to the vertical position. Okay, so that is going to be, you probably know, so it's 90 degrees. And the reason for that, maybe I'll do it in blue, is because it's a quarter of the full turn. So it's 360 divided by 4. Okay, now if we actually go a half turn, and our terminal side is on the negative x-axis, then we've done half a turn, so that's going to be half of a full turn, And that's why a straight angle is 180 degrees. Okay, now I'm going to draw just one of these, and I'm going to leave the other one for you to do. So I'm going to do the 61. Okay, so if we draw, so 60 degrees is a third of 180. So it's actually a 6. So it's 180 divided by 3, or 360 divided by 6. Okay, so if you wanted to draw it, what you can do so I'm going to split up the 180 because it's only half, but split it into 3 parts. So 3 equal parts means that I would split like that. So this part equals that part equals that part. Okay, so the reason why 3 is because I'm taking the 180 and dividing it into 3 bits. Okay, so then one of these bits, so the first bit, that is what 60 degrees looks like. Okay, so that's how you can do that. So again, I'm going to leave the negative 135 degrees for you. So you want to think about what some nice things that combine to make 135, and then try and draw them in standard position. Okay, so now another way to measure angles is to use radians. So I'm going to start by defining 1 radian. Okay, so if the radius of a circle is r, and the length of the arc subtended by the central angle is also r, then the angle measure is 1 radian. Okay, so I'm going to draw you a picture of what that looks like. Okay, so we have a circle. Okay, and then we have, so in the center, the central angle, so that's the vertex is the center of the circle. Okay, so it has, okay, so it looks something like that. Maybe that's not very good. Okay, maybe that's a bit better. Okay, so let's say that that's our angle. So the idea is, so this length is r. Okay, this length is also r, the radius of the circle. So when this length is also r, that's when the angle measure, so this angle here, theta, let's call it, is the measure is going to be 1 radian. Okay, so this arc between the initial side and the terminal side, the arc of the circle, that is the arc subtended by the angle. Okay, so when that is equal in length to the radius, that's when you get 1 radian. Okay, so that's a bit weird, maybe, to think about. But the idea is actually really neat. So basically, when you have your terminal side, you just want to think how many radiuses do you need to go to get to that. Okay, so this is 1 radius. So let me just write. So this is 1 times r. Okay, so then if we had a right angle, well, let's do actually a full turn first. I don't know why they didn't do that. So if we do a full turn, I'm going to just get a different color here. Okay, so if my initial side and my terminal side are actually the same, Okay, so that whole thing, then the arc subtended by the angle is going to be the full circle. Okay, so the arc length, oops, is going to be the circumference of the circle, which is 2 pi times r. So that means that we needed to go 2 pi radiuses to get all the way around. So that means that the angle measure is going to be 2 pi. Okay, so it's 2 pi times the radius. So you always take the arc length and divide by the radius is how you find this. Okay, so then if you wanted a right angle, it's going to be 2 pi r divided by 4, because you've only gone a quarter of the way around. So you've taken a quarter of the circumference. So that's going to be just pi r over 2. And then if you divide that by r, so maybe I should write this. This is pi over 2 times r. So this is the radian measure. Okay, so it's the multiple of r that you have. Okay, so this radian measure, the right angle, is going to be pi by 2. If you have a straight angle, then you're going to have, so this one, so you have your total circumference, 2 pi r, divided in half, because you're only taking the top half. So that's pi times r. So it's the multiple of r here is pi. So a straight angle is pi radians. Okay, now for us in mathematics, the default angle for the default measure for angles is radians. So unless it has a degree symbol, you should assume that it's in radians. Okay, now for this one, I'm going to draw the negative pi by 6. The negative pi by 6 angle. So that's the radian measure. Okay, so what would that angle look like? So we're going to, actually I should have done the circle first. So let me do the circle. Okay, and then down the middle. Okay, something like that. So our in standard position, oops. So this is our initial side. Now we want to go in the negative direction. Okay, so we're going to be going this way. And what you want to think of is it's pi into 6 parts. So negative pi would be all the way to the negative x-axis. So what I want to do is break that up into 6 parts. So I break it up into half, and then I break each half into 3 equal parts. Okay, so now I have 1, 2, 3, 4, 5, 6. So I've broken up the pi into 6 parts. So pi by 6 is just going to take the first of those parts. Okay, so this measure, this angle, has measure negative pi by 6 radians. Okay, so that's what it would look like. I'm going to leave the pi by 4 for you to do. Okay, so let's talk about converting between radians and degrees. So because a half turn in radians is pi radians, but in degrees is 180 degrees, we know that this equation needs to be satisfied. Okay, so if you just remember that, then if we take it and divide by pi on both sides, then 1 radian is going to be 180 divided by pi degrees. Okay, or if we divide both sides by 180, then pi over 180 radians is going to equal 1 degree. Okay, now this is what we use to switch between degrees and radians. Okay, are these two conditions. So if I want to convert from x degrees to radians, what I'm going to do, I'm just going to do a little explanation here. So x degrees is x times 1 degree, right? And 1 degree is pi over 180 radians. So this is going to be x times pi over 180 radians. So what I need to do is multiply x by pi over 180. Okay, and that's going to convert me to radians. If I want to convert y radians to degrees, I'm going to do the other way. Okay, so y radians is y times 1 radian. And 1 radian is 180 over pi degrees. Okay, so now if I multiply by 180 over pi, that's going to convert me to degrees. Okay, so let's do a couple of examples, and then I'll leave some for you to do. So let's convert 330 degrees to radians, and we're going to express as a multiple of pi. So 330 degrees is 330 times 1 degree, so it's going to be 330 times pi over 180. And now we're in radians. Okay, so that's 330 pi over 180, which can be simplified to 11 pi divided by 6. So 330 goes into both of those. Okay, so that is, that is the measure in radians. Okay, now I'm going to leave number 4 for you, and let's do number 6 here. So 1.5 radians, okay, is going to be 1.5 times 180 over pi degrees. Okay, now we're in degrees. Now 1.5 is 3 over 2. Okay, so that's going to be 2 goes into 180 90 times. So 3 times 90 is 270 over pi degrees, which if you compute is approximately 85.94 degrees. Okay, so this is the exact answer versus the rounded answer. Okay, now I'm going to leave the other examples for you to do. You can also talk about the arc length and the area of a sector. Okay, so we know that if a circle has radius r, then it has circumference, so the arc length, 2 pi r, and the area is pi r squared. Okay, but what if we just want the arc length or the area of a slice of the circle? So, and this is a central angle, so this is the center of the vertex here. Which, this is going to be in my way. So one thing you can use, so if I had another angle, okay, so maybe theta 1, and let's call this arc length S. Okay, is that length there? And this arc length can be S1. So if you take the one angle and divide by the other angle, the arc lengths should also be, the ratio should be the same, as should be the area. Okay, so the area of the sector, so this I'm calling A and this I'm calling A1. So those should, the ratio should be equal. So if you take theta, so theta 1 I just drew an example. So what I actually want to use for theta 1 is 2 pi. Because then S1 is the full circle because I'm doing a full turn. So that's going to be 2 pi r. and A1 is going to be pi r squared. Okay. So this is the reason why we're doing this is we get some nice formulas. Okay, so this is true for any theta and theta 1. But here we're going to get some nicer formulas. So if we use those and we want the arc length, we want r, or s, sorry, the arc length, then theta divided by the angle theta 1, 2 pi, should be equal to s divided by the arc length, which is 2 pi r. So then that's going to give me 2 pi r times theta is equal to 2 pi times s. Obviously the 2 pi's cancel, so the s is r times theta. Okay, so that's what you can use to figure out the arc length. So the arc length is always the radius times your angle in radians. Okay, so this is how you can find the arc length of your section. And similarly, the area, so if I take, let's do this in pink, so if I take theta over theta 1, and theta 1 I'm going to use 2 pi again, then my area of my sector is going to be, divided by the area of my sector for theta 1, which is pi r squared. Those should be equal, which means that, not 2, sorry, that pi r squared theta is a times 2 pi. So the pi's cancel, and if I move the 2 over, I get the area is 1/2 r squared theta. Okay, so that's how we can find the area of the sector. Okay, so A is going to be 1/2 r squared theta. So just to give you some justification about where this comes from. So this is the area of the sector created by angle theta. Okay, and the circle of radius r. The arc length and the area formulas do not hold if they're in degrees. Okay, so this is always angle measured in radians. Because otherwise, if we're measuring in degrees, then we also need to compute the other things in terms of degrees as well, instead of in the radians. So, yeah, it doesn't work. So let's just do an example of this. Okay, so given a circle with radius of 6 centimeters, so r equals 6 centimeters, we want to find the arc length and the area formed by a central angle, so theta, of 2 radians. Okay, so that means that my arc length, which I'm calling S, is going to be r times theta, so 6 times 2, which is going to be 12, and the measure here is centimeters. Okay, and the area of the sector is 1/2 r squared times theta, so that's 1/2 times 6 squared times 2, which is going to be 36, and this is going to be centimeters squared. Okay, so you just need to plug into the formulas now that we have them, and you can also find the area of the sector and the arc length. So notice that, maybe I should draw this. Okay, so there's our circle. So this radius is 6. Okay, and so we went 2. So maybe it's something like that. Okay, this is also 6. This is our vertex. So this bit, okay, is S, and it's 12. So because it's 2 radians, you could also do this as, so it's 1 6 and then 2 6s. So the length is 2 times r, so that's why the radian measure would be 2, right? So it's the multiple of r, how many radiuses we need to go in order to get to the terminal side. Oops. Okay, so that's the idea. Oops, I'm in pink. These should be keep going because they're rays. They shouldn't stop at the circle. But yeah, you can also think about that's what the radian measure is. So we went 6 and then we went 6 more. So we did 2 6s because the radian measure is 2. Okay, so by definition of the radians, that's what happens. So the arc length is 2 of the radiuses. Okay, so that's why we had this angle measure of 2 radians. So that's the sort of introduction to angles and how to measure them.